Ebunoluwa carrying out an experiment to prove Hooke's law. Hooke's law states that provided the elastic limit is not exceeded, the force applied is directly proportional to the extension produced. Firstly, you take your meter rule to measure the original length of the spiral spring. Then after you measure the original length, you add your weight, which is 200 grams, or it can be varied by your experiment. Then now measure the length of the spiral spring after you added the weight. Then after this, you subtract the length of the spiral spring after you added the weight minus the original length. Then you now take your number of oscillations to be 10. Then you now take your measurements. After you find the time taken for it to complete 10 oscillations, you can use this small t to calculate your period t square and other calculations that are necessary.
Over here, I'll be performing a simple harmonic motion experiment on a pendulum bulb. And to go about this experiment, I'm going to need some apparatus. This is my retort stand. This is my pendulum bulb, and here is my timer. And I also need the thread to calculate the length of the pendulum bulb. So I'll place my pendulum bulb at a small angle, then I displace it. I'll wait for some time, then I start my stopwatch for 20 oscillations, then I tabulate my readings. Then for different lengths of the pendulum, I calculate my reading, I tabulate it, then I'll calculate my t square, and I'll calculate my length. So I'll plot my graph of t square against L to form my acceleration due to gravity, which is the small g.
Over here we have the setup to perform an experiment to verify Ohm's law. So Ohm's law states that the potential difference across a metallic conductor is directly proportional to the current passing through it, provided that all physical conditions remain constant. To perform this experiment, we need all these apparatus, such as the ammeter, voltmeter, resistance box, rheostat, a pair of batteries, and a battery holder, and a key to close the circuit. According to this circuit diagram, these apparatus need to be connected in series to perform this experiment. To perform this experiment, we need to take readings of the voltage and the currents, tabulate them, and do various evaluations to plot a graph of V inverse against R inverse, calculating the slope to verify the experiment.
We want to test the internal resistance of this unknown wire. So today we're going to use this 2-gap meter bridge, this rheostat, this pair of battery with a battery holder, a key, and a voltmeter and ammeter. Voltmeter calculates the volts and the ammeter calculates the current. And here on our current diagram, it's shown that we connect all of this, including the batteries, in a circuit in a series connection, meaning the same current will pass through all of this. So when that has been connected, we use our voltmeter to calculate our volts V and our ammeter to calculate our current I. Then we'll plot our graph of I against V. Then we'll get our slope and use the graph that means V, the voltage, when the current equals to 0.
As you can see that the school is well equipped with ultra-modern laboratory. We can see that some of the students just perform an experiment on electricity, then the simple pendulum. So we are here to take care of both the theory and the practical aspects of the subject. So not like the other school that they will just expose the students to only the theory aspect of physics. So we advise all parents to bring their wards to the school, not just physics alone. We have a standard chemistry lab also, standard biology lab. So we advise all parents generally to patronize the school.
I am at Ebunoluwa International School, and I'll be performing an experiment on separating techniques. So here I have my oil and water, which are immiscible liquids, and I'll be separating them. My apparatus, this is a retort stand, this is my separating funnel, and here is my beaker to obtain my filtrate. My filtrate in this case will be water. So I will just roll over the stopper here, and then my water will drip into the beaker. Once the liquid is done, the oil will stay here, the stopper, and I'll have my water as my filtrate.
We learn how to prepare salt in our salt analysis. Here I have calcium trihydrocarbonate 4, which is added to the test tube. Then we add water and our reagent, dilute sodium hydroxide. So what we formed is white precipitate of an insoluble salt.
We are carrying out a practical operation on volumetric analysis, titration to be precise. This is our burette, and we'll be pouring an acid into it. Okay. Then this is a pipette which you would use to take our base. And this is a chronicle flask. Then we'll be adding our indicator, which is methyl orange. We'll be adding just a few drops. Then we'll be mixing it with our acid to meet our endpoints.
We want to carry out a separating technique, specifically filtration. So we first took our retort stand, our glass funnel, our filtered paper, and our beaker. So we had to take a soluble and insoluble salt, mix it together in their dry form, now add water to make it an aqueous solution. Now that we have poured the aqueous solution into the filter paper inside the funnel, the soluble salt will follow the water out of the filter paper and into the beaker down, and the rest as the filtrate, and the residue inside the filter paper is insoluble salt.
You're welcome to Ebunoluwa International School Chemistry Ultramodern Lab, where we take our world in practicals on various aspects, and some of which we have is separation techniques, as we can see we have there, and over there we've also learned about volumetric analysis as well as qualitative analysis. I would like you to bring your word here to Ebunoluwa International School, where we'll bring them into the world of science.
Welcome to the Biology Lab of Ebunoluwa International School. This is where we take on all practicals regarding from the simplest forms of life to the highest form of life. But today we'll be talking about the parts of the body. Let's go to the brain. The brain has 3 compartments and is responsible for all the activities that take place in the body: the forebrain, the midbrain, and the hindbrain. Let's not waste any time and move to the excretory system. In the excretory system, we have organs that are responsible. We have the kidney, which is connected to the bladder by the ureters. This is the bladder, and from this bladder, we move to the urethra.
This is the alimentary canal of a human being. Digestion takes place in the mouth first of all, which has 2 enzymes mainly, which has 2 functions mainly for the chewing, mastication of food, and for the churning, for the mixing of food. After that, food is passed through the esophagus into the stomach. The stomach has one function, which is to store food and convert bolus to chow. Pardon, I didn't say the meaning of bolus. Bolus is the food that passes through the mouth into the small intestine, into the stomach, and this is the small intestine, which has 2 functions, which is digestion and absorption of nutrients by tiny finger-like structures known as villi. Then this is the small intestine, which food remain till they are passed out by the anus.
The teeth is a hard mineral-rich structure which is used in chewing and breaking down food for the human body. A normal adult has a number of 32 teeth in the body, which is divided into 4. The incisors, the canine, the molars, and the premolars. Then we have the tongue. The tongue has 4 sections. The upper section is for tasting sweet things. The left side, upper left and right side is used for tasting salty things. The lower left side and right side is used for tasting sour things, and the down part is for bitter things. So the canines are used for tearing and cutting meat, while the incisors are used for biting meat. Then we have the molars, which are used for chewing and masticating food substances in the human body.
I am talking about the reagents in the biology lab. So first we have the Unveiling solution here, which is used for the detection of carbohydrates in foods, other foodstuffs, and in animals, in plants, if the carbohydrate is good enough or is sufficient. Then we have copper sulfate solution, which is green in color. It is used for the preservation of animals in the biology lab. It prevents them from getting rotten, and you can use them in other practicals after you have used them before. Like this frog now, it has been here for so many months and it is still in one piece because of the chemical, the reagents that has been used to preserve it. And if you leave it here for 3 other months, then it will still remain the way that it is. This is sodium hydroxide. It is also used for the preservation of animals that are used in the practicals. It is used to preserve them from rotting and from getting spots. So if they want to use it for other practicals, you can still remove them from their containers and use them for the practical. Then the last one I'm going to talk about is Sudan solution. Sudan solution is used for testing fat and oil in foods. Like you can detect if there is fat and oil in the food, detect how much it is in the food. Then Sudan solution, you just take a little amount of it and you measure it. Everything in the biology lab is measured correctly so that we don't have explosions or we don't have biological disruptions.
This is a human skeleton. First, what is the skeleton? The skeleton is the bony framework of the body, which aids movement and gives shape to the body. Then here, I'll be talking about the skull. Here is the cranium, we have the orbit, the nasal cavity. And here, we have the maxilla, also known as the upper jaw, and the mandible, also known as the lower jaw. Here, we have the atlas, which aids nodding, and then the axis, which aids rotation. Here, we have the clavicle, also known as the chest bone. And here, we have the scapula. Over here, this is the sternum, and here, we have the humerus. This is the ulna and the radius. Then moving here, we have the carpals, metacarpals, and phalanges. Then this is the pelvic girdle. Here is the femur, the longest, strongest, and hardest bone of the body. Here we have the patella. Moving here, we have the fibula and tibia. Moving down, we have tarsals, metatarsals, and phalanges as well. So moving to my partner, she'll be talking about the human joints.
The two types of joints we have the movable and immovable joints. So under the movable joints we have the hinge, the ball and socket joints, the pivot, and sliding and gliding joints. So the hinge joint is located at the elbow area. Then the ball and socket joint is located at the shoulder and hip area. We have the pivot joint located at the neck. Then lastly, we have sliding and gliding joints, which is located at the wrists and ankle.